If the engine cooling fan on your Kia Sportage is not working properly, or if it only turns on at high speed, it could be due to a faulty cooling fan resistor. The cooling fan's resistor is responsible for controlling the fan's low and high speed settings, helping to regulate the engine temperature, especially when idling or driving at low speeds. When this resistor fails, the fan either won't run at all on lower speeds or might only kick in at full blast, which can lead to overheating or inconsistent engine cooling. Ignoring this problem can put unnecessary strain on your cooling system and could even lead to more serious issues like a blown head gasket if the engine overheats frequently. The cooling fan resistor is mounted directly onto the radiator fan shroud near the fan motor, but it is under the engine air intake duct, so you won't be able to see it right away. To get access, you will have to remove the air intake duct first. The duct is held in place with two simple clips. Just release these clips and then lift the duct straight up and out of the way. Once the duct is removed, the resistor will be visible on the radiator fan shroud, making it much easier to reach and replace. As you can see, there are two electrical connectors attached to the resistor, which you will have to disconnect before you can take out the resistor. Press down on the locking tab of the connector and pull it straight off. The connectors on the resistor are usually very tightly seated, so don't be surprised if they don't come off easily. Start by pressing down firmly on the locking tab, then wiggle the connector gently while pulling it straight out. If it feels stuck, take your time and work it loose, instead of forcing it, as you don't want to crack the plastic housing or damage the pins inside. With the connectors removed, use a 8mm socket to remove the bolt holding the resistor onto the fan shroud. Once the bolt is out, slide the resistor out of its position. Here is a close-up of the resistor. You can test this resistor with a multimeter. The cooling fan resistor has two terminals on the output side. One is ground and the other is positive. On the opposite side, there are three terminals for the input: ground, high fan speed, and low fan speed. For this test, set your multimeter to the resistance mode. Let's start by testing the ground circuit first. Place one probe of your multimeter on the ground terminal of the input side and the other on the ground of the output side. The reading should be 0 ohms, showing a solid ground connection. Now move the probes to the positive output terminal and high-speed input terminal. The resistance here should be 0 as well, since high-speed bypasses the resistor. If it shows open or infinite resistance, then the high-speed circuit is faulty. Next, test between the positive output terminal and the low-speed input terminal. You should get a small resistance reading, usually around 0.5 ohms. If the meter shows open circuit or infinite resistance, it means the low-speed resistor is burnt out. By checking all of these, you can confirm whether the resistor is working correctly or if it needs replacement. Now back to reinstalling the resistor. Line it up with the mounting points on the fan shroud and reinstall the bolt. Tighten it snugly, but don't over-tighten. The recommended tightening torque is 2.8 to 3.2 Nm or about 2 to 2.4 pound-feet. Next, reconnect both the electrical connectors until you hear it click securely into place. If the fan still does not work properly after replacing the resistor, it could be due to other issues in the cooling system. For example, one of the relays for the cooling fan may have gone bad. Another possibility is a worn out or damaged cooling fan motor itself, which may need testing or replacement. Additionally, inspect the wiring harness and connectors for any signs of corrosion, damage, or loose connections that could interrupt the electrical flow to the fan. It could also be due to a faulty engine coolant temperature sensor or ECT sensor. The ECT sensor monitors the engine's temperature and sends signal to the ECU to turn on the cooling fan when needed. If the sensor is giving incorrect readings, the fan might not activate at the correct temperature, causing overheating. Along with checking the fuse, relay, and fan motor, it's a good idea to test or replace the ECT sensor if you are still having issues. If you found this video helpful, give it a thumbs up and subscribe to EaseJoin for more DIY car repair guides. Thanks for watching.